Good morning, good morning, good morning. Hello, hello, hello. Hi, hi, hi. Going to ask some fun questions. Let's see. What are the deep philosophical lessons from the Babylonian method of finding square roots? Asking this question to Gemini Pro. Let's see, just for fun. Nothing serious here. I did not. um I did not adjust the temperature. It is the default temperature for Gemini 2.5 Pro or any other parameters. I have not changed any other parameters. Everything set as default. So let's see the answer. It's showing thinking. Sometimes it's just show thinking and stops like that is the answer. I think that is the case in this case also. So we'll hear.
The Babylonian method for finding square roots, dating back to ancient Mesopotamia, around 2000 to 1600 BCE, offers more than just a historical mathematical technique. It provides a window into early mathematical thought and carries several deep philosophical lessons that resonate even today.
Yeah.
At its core, the method is an iterative process. Start with a guess for the square root of a number s, then refine this guess by averaging it with s divided by the guess. Repeating this process brings the approximation closer and closer to the actual square root. Here are some of the profound philosophical insights that can be drawn from this ancient algorithm. 1. The nature of approximation and the pursuit of exactness. The Babylonian method is a powerful illustration of how humanity grapples with the concept of precision. For irrational numbers, like SQRT2, the exact value cannot be expressed as a finite decimal or fraction. The Babylonians understood that while perfect exactness might be elusive in representation, it could be approached systematically. This highlights a philosophical stance, that useful and highly accurate knowledge is attainable even when absolute ultimate truth, in the sense of a complete finite representation, is not. It underscores a pragmatic approach to truth, where the value of knowledge lies in its predictive power and utility. The famed YBC 7289 tablet, for instance, shows an approximation of SQRT2 to a remarkable degree of accuracy. 1.
Oh, okay. So there is a quite famous tablet YBC 7289 from the Babylonian civilization. Okay, let's continue.
24, 51, 10 in sexagesimal, which is about 1.4142126 in decimal, showcasing their sophisticated understanding and acceptance of approximation. 2. The power of iteration and incremental progress. The method's iterative nature, repeating a simple process to get successively better results, is a fundamental concept with broad philosophical implications. It demonstrates that complex problems can often be tackled by breaking them down into smaller, manageable steps, and that consistent effort can lead to significant advancements. This mirrors many processes in learning, scientific discovery, and even personal development, where gradual refinement and repeated attempts lead to mastery or deeper understanding. It's a testament to the idea that progress is often a journey of incremental improvements rather than a single leap of insight. 3. Pragmatism and utility in knowledge. Babylonian mathematics in general was deeply rooted in practical applications, such as land surveying, construction, resource management, and astronomy. The square root method, essential for calculations involving diagonals and areas, as seen in problems related to the Pythagorean theorem, which they understood in a practical sense, exemplifies this pragmatic orientation. The philosophical lesson here is the importance of knowledge that works. The Babylonians sought methods that yielded useful results for real-world problems, emphasizing the instrumental value of mathematics. This contrasts with a purely abstract or Platonic view, where mathematical truths exist independently of their application. 4. The concept of convergence and limits, Although the Babylonians may not have had a formal theory of limits as developed in modern calculus, their method intuitively grasps the idea of convergence. Each iteration brings the estimate closer to the true value. This implies an understanding that a sequence of approximations can approach a specific, fixed value. This foreshadows later, more formalized mathematical concepts of limits, which are foundational to.
So once again, this is the Babylonian square root method. So the algorithm starts with an initial guess x, then compute y equals to s by x. So idea is x times y equals to the number s that we are trying to find square root of. So x and y are like initial guesses. Then take the average x plus y by 2, set x to this average, and repeat until desired precision is found. So key idea is based on the principle that if x is an overestimate to the square root of s, then s by x will be an underestimate, and the average of these two values will provide a better approximation. For instance, here the square root of 16 done in 5 iterations. So starting with x equals to 16, y equals to s by x equals to 1, averaging as 8.5, and error is the difference between x and y, that is 15. So when it converges, the difference will come to down to 0, and x times y will be equals to s. So that's the general idea. For instance, if we do another calculation like let's see, so first approximation x is the value, the original value that is given as input, 1,165,629, y equals to s by x 1. So average is giving 82,815, and error is the difference between these two. And then we keep on iterating. So now the average value becomes x, and y becomes again once again s by x, and we keep repeating. Next time the average will become the next average becomes the next x for the next iteration, and y is once again s by x, and we keep on going 6, 7, 8, 9 up to 12 iteration. At the 12th iteration, we said that we have converged enough to the actual value, which we can find from JavaScript method.square root method 406.9754293, and Babylonian method approximation is 406.9754330. Just after 12 iteration, we can see that we are accurate, very close, like up to 5 decimal points. So this is the Babylonian method. Okay, so let's continue.